Okay, guys, next section here is 5.2. It's called polynomials, linear factors, and zeros. Okay, this is going to expand on our knowledge of solving quadratics by factoring. When it's talking about polynomials, what we're going to start to deal with here is problems or polynomials whose degree is greater than 2. Okay, so we're going to solve this one by factoring, or we're going to write it in factored form. If it says factor, stop your parentheses. If it says solve, set your parentheses equal to 0. Okay, so let's not differentiate between those two things. Let's just make sure that we read the directions well. Okay, and I'm going to get ready to do a problem here for you. So again, we're going to solve by factoring. The directions could just say factor. Okay, but what we've got here is x to the third minus 2x squared minus 15x, and this is set equal to 0. Of course, to solve by factoring, it has to be set equal to 0. Okay, so what we want to do is use our knowledge of factoring out a GCF. This is currently a cubic trinomial, but I can factor out a GCF and get it down to a quadratic. So there is no number GCF, but I can pull an x out. What I'm left with is x squared minus 2x minus 15. Okay, and now I'm down. This thing right here is now a quadratic that I can solve by factoring. I'm looking for two numbers that multiply to be negative 15 and add to be negative 2. That would be minus 5 and positive 3. And now to solve, I'll just set my all my factors equal to 0. So I'll set x equal to 0. That's an answer. I'll set x minus 5 equal to 0. And of course, when I add 5, I get that x equals 5. All right, and then I'll set x plus 3 equal to 0. And when I minus 3, I get x equals negative 3. So what's going to happen on all of these is your GCF is always going to involve something that starts that has an x in it. Okay, and of course, then once you pull that x out, all right, then you're left with a quadratic that you can use one of your factoring methods to solve. We'll scroll down and do another one and give you another quick example here of something that might be a little bit different. How about x to the fourth minus 2x to the third minus 8x squared. Okay, so what this is going to do is this time the GCF is x squared. I can pull an x squared off of all these things. I'm left with x squared minus 2x minus 8. Okay, so I've got my x squared. I'm now looking for two numbers that multiply to be negative 8 and add to be negative 2. That would be negative 4 and positive 2. Now, what you need to, next vocab word here is what's called multiplicity. Multiplicity means the number of times that each 0 occurs, okay? So x squared is actually x and x. We need to set both of those equal to 0, okay? So the answer 0 has multiplicity of 2. It happens twice. This would give me an answer of 4. This would give me an answer of negative 2. Okay, so multiplicity, it means it happens more than once. All right, let's keep going here. Try to give you one more example of a good one. Here's one. How about we go with x to the third minus 36x equals 0. Okay, so now again, I can pull out an x, and I'm left with x squared minus 36. Okay, and what happens here is that thing is now a difference of squares. Okay, in fact, square root the front, put square root the front, which is x, write it in front of both parentheses. Square root the back, which is 6, write it in back of both parentheses. Make 1 plus and 1 minus. Again, this gives me an answer of 0. This gives me an answer of negative 6. This gives me an answer of 6. Each of those have multiplicity of 1. Okay, so you're factoring it out there and then finding the zeros. Okay, factoring out an x using some sort of factoring of a quadratic to find these zeros. Okay, not too bad. Not too bad. Okay, the next thing is let's go back to this idea of multiplicity. We can do that. And it's a fairly simple idea. It says find each 0 and state its multiplicity. Okay, find each 0 and state its multiplicity. Let's say I had this. Okay, well, this right here would give me an answer of negative 2, and it would have a multiplicity a mult of 3. It happens 3 times because of this right here. Really, x plus 2 cubed is x plus 2, x plus 2, x plus 2, right? That 0 is occurring 3 times, okay? This right here gives me an answer of x equals 4, okay? And again, now this is happening with a multiplicity of 2. It's happening twice. Okay, so this is very easy. If something's only listed once, then it only has a multiplicity of 1, okay, et cetera, et cetera. It's fairly easy of an idea. Let's try this. One more type of problem we've got to go over here. What, need a new document, I guess. Okay. We want to write a polynomial when given its zeros, okay? So let's say that we know that x was equal to 5, 6, and negative 2. Okay, if 5 was an answer, then x minus 5 was a factor, because if I set x minus 5 equal to 0, I get that answer. If x was a 0, then x minus 6 was a factor. If negative 2 was a 0, then x plus 2, the opposite of that, was a factor, okay? And now if I want to rewrite the polynomial with these, now I'm just going to FOIL these together, okay? I actually am going to have to do foiling twice. So let's start here. I've got x squared minus 6x minus 5x plus 30. Okay, we're going to simplify this first. That's x squared minus 11x plus 30. And I'm now going to factor that with this, FOIL that with this factor I haven't touched yet with this x plus 2. This is still a FOIL problem. Okay, here we go. That's x to the third plus 2x squared. That's minus 11x squared minus 22x. That's plus 30x plus 60. Now I'm going to combine my like terms. I've got x to the third minus 9x squared plus 8x plus 60. And that, my friends, would be the final answer. Okay, FOIL 2 of them together and then FOIL again. Let's do one more. One more, and then we'll be done with this video, okay? What if they told you that the roots or the zeros or the x-intercepts, again, all of those are synonyms, were 0, x equals 0, 4, and negative 1/2. Okay, couple things here, okay? If x equaled 0, then just x was a factor because they factored out an x, they set that x equal to 0 to get 0. If 4 was a 0, then x minus 4 was a factor. Now watch this one, okay? In order for me to get a 0 of negative 1/2, I had to have a factor that looked like this, okay? I'm going to tell you that the factor that made this was 2x plus 1. Here's how I know that. They had to set this thing equal to 0. And what I know is that they needed to minus 1 and then divide by 2. So look, minus 1 and then divide by 2. Okay? So I know that it's 2x plus 1. Now here's what I'm going to do. I'm going to FOIL these two things together, the two parentheses, and then I'm going to distribute my x through. So I've got 2x squared plus x minus 8x minus 4. Okay, that's 2x squared minus 7x minus 4. And now I'm going to distribute this original x through to get my final answer of 2x to the third minus 7x squared minus 4x. All right, that's all the problems you'll be asked to do tomorrow. I'll see you tomorrow. Happy Friday.